This is TechCrunch. Amazon CEO Andy Jassy's annual shareholder letter reads something like a Kendrick Lamar diss track, if the rapper was a corporate-speaking, talking CEO and not a poetic Pulitzer Prize-winning musician, that is. Meaning you have to know the history to understand all of the competitors Jassy is taking aim at, alongside cute personal stories about his unrealized dream of being a sportscaster and watching hockey games with his dad. Of course, Jassy doesn't throw the gauntlet down directly. He takes a more nuanced approach. For instance, in his challenge to Nvidia, he wrote, "We have a strong partnership with Nvidia. We'll always have customers who choose to run Nvidia, and will always support these chips in its cloud." But he also says, virtually all AI thus far has been done on Nvidia chips, but a new shift has started. AWS customers, he says, want better price performance, meaning Amazon's own homegrown Trainium AI chips. Jassy says demand is so high for this chip that capacity for the newest one, Trainium 3, is nearly sold out. Remarkably, he says that capacity is also nearly sold out for Trainium 4, which is still 18 months away from being available. That means that Trainium has hit a $20 billion annual revenue run rate. But if Amazon were a chip maker that sold its wares to others, it would be at $50 billion ARR, he postulates. Now, granted, Nvidia did $215.9 billion in actual revenue last year. Nvidia may not be shaking in its boots just yet, but Jassy presents Trainium as a formidable up-and-comer. Jassy did not spare Intel either. He pointed out that AWS's homegrown Graviton CPU, a competitor to the Intel x86 architecture, is now used expansively by 98% of the top 1,000 EC2 customers, aka some of the biggest companies in the world. Two companies even asked to buy all of our Graviton instance capacity in 2026, and he said that we can't agree to those requests given our customers' needs, but it gives you an idea of the demand. He promised that Amazon's Starlink competitor, Amazon Leo, scheduled to launch in mid-year, is already succeeding as well. It's won contracts from Delta Airlines, AT&T, Vodafone, Australia's National Broadband Network, NASA, and others. Interestingly, he also said Amazon could be looking at selling robotics one day. It may turn all the data from its 1 million warehouse robots into robotics solutions for industrial uses and consumers. Now, is there an Amazon humanoid in our future? We'll see. He talked up other Amazon businesses too, like same-day delivery, groceries, and drones. But mostly, Jassy tried to make the case for the hundreds of billions of dollars of capital expenditures he's committed. In February, he announced plans to spend $200 billion this year on capex, mostly building out AWS data centers. Now, that's more than any of the other major tech companies, which are also spending big on capex. Jassy's pitch to shareholders makes sense considering Amazon's stock plunged to below $200 a share and has not recovered. He wrote, "We're not investing approximately $200 billion in capex this year on a hunch," using as an example that his deal with OpenAI included the model maker pledging to spend $100 billion on AWS. Of course, there are those who doubt OpenAI will meet all of its spending promises. In a nod to that, Jassy insisted that beyond OpenAI, there are several other customer agreements completed and unannounced, or deep in process, lined up to buy the AWS capacity. We'll have to wait and see. Those who cause a bubble are never the ones who see or admit to its existence. Jassy wrote, "I followed the public debate on whether this technology is overhyped, whether we're in a bubble. But," he declared in this letter, that for Amazon at least, that is not the case. Rare earth elements might represent small slivers of the global metals market, but they're big sticks on the geopolitical stage, where China wields its considerable heft as a bargaining chip during trade disputes. Countries like the U.S. have started taking steps to reverse China's dominance. New mines have opened and manufacturers are popping up to make magnets and motors, but it has been a slow process. China built its position over several decades. Zach Detweiler, co-founder and CEO of Radify Metals, told TechCrunch the unfortunate part is that in order to be able to support an entire industrial base, you've got to have that whole supply chain node matched in terms of capacity. He thinks one node in particular has been overlooked, the part that turns metal oxides into pure metals. That's this missing middle we've identified, he said. Most metal refining uses either heat or water in combination with other elements to strip metal oxides of their oxygen, leaving pure metal that's easier to incorporate into alloys that make, for example, stronger magnets or more efficient electronics. Both processes are effective, but also highly polluting. Another option has been known for a while, but it was considered too expensive to use in commercial production. It involves stripping oxygen using plasma, which is basically a superheated soup of super energetic particles. The process's only waste is water vapor. Now, Radify thinks it has cracked the plasma problem through a combination of more efficient power electronics and some clever engineering to handle the metallic powders. It recently gave TechCrunch an exclusive look at its technology. The startup has raised just under $3 million from investors, including Overture, Founders Inc., Mana Ventures, and Acquia Capital. Radify said its reactor can transform a wide range of metal oxides. Today, it's focused on dysprosium and samarium, two rare earths that are key ingredients in magnets and electronics. Inside the reactor, hydrogen is heated until it forms a plasma. Then metal oxide power is blown into the chamber where it's reduced. That is, the oxygen that's bound to the metal is removed. On the other end, pure metal emerges. Need to make a different metal? Well, just tweak the operating parameters for the reactor. The design allows the company to make smaller reactors compared with the massive equipment the industry uses today. That could reduce manufacturing costs while also adding some flexibility. Detweiler said, when China bottoms out the price of dysprosium and starts selling it for $1 a kilogram because they want to kill a lot of the businesses out there, we don't die because we can pivot to titanium or zirconium. We become substantially more resilient to a lot of the volatility that's endemic of the metals industry. Currently, the 5-strong Radify team is refining the technology in its lab in Campbell, California. It hopes to produce several kilograms of pure metal per day by the end of the year. In the coming months, it plans to raise more money to build a pilot reactor capable of making up to 100 kilograms per day. If Radify can reproduce the results it's seeing today at a larger scale, well, it could give Chinese producers a run for their money. Today, rare earths outside of China sell for several times the Chinese price. Detweiler thinks that Radify can produce rare earths that cost just 50% more than China's prices in the near term. But, he said, he also expects Chinese spot prices to go up. Once the company starts scaling, it expects to reach parity and possibly lower. Beyond rare earths, the company is exploring a range of other metals, including hafnium, uranium, scandium, and titanium, which are used in electronics, aerospace, and other fields. The plasma-based technology also works on more widely used metals like iron and aluminum, though currently it's not efficient enough to challenge the incumbents. But if it eventually gets to that point, Detweiler said that we'll have completely changed how humans make metal. That's all for now. You can find more stories like these at TechCrunch.com.